RAM, RAM. R stands for reliability, A stands for availability, and M stands for maintainability. In this few minutes, I am going to present these basic concepts related with this topic RAM. RAM, if you think, we talked about reliability. Unreliability brings maintenance into the picture, but we never talked about maintainability. So, reliability and maintainability are often considered complementary disciplines. They complement to each other, as both contribute to system availability and are important part of design. So, studying the concept of maintenance, you must know about maintainability. What is maintainability? Maintainability is defined as, in a very simple term, as ease of maintenance. Let's look at the qualitative definition. There can be quantitative definitions and qualitative. First we'll look at the qualitative definition. And it is defined as, it's a little longer, but maintainability is a relative ease and economy of time and resources with which an item can be retained in or restored to. Like an item is working, and if I do a action to keep in running state, that is retaining in. You should compare with the definition of maintenance, or restoring it to operating condition. Under a specified condition, when maintenance is performed by personnel having a specified skill levels using prescribed procedures and resources at each prescribed level of maintenance and repair in this context. And of course, it is a function of design. Now let us look at quantitative definition. This is the concept we will be using. This definition we'll be using in our calculations and our future maintenance planning, etc. calculations. Maintainability of a system is defined as the probability that it can be retained in or restored to a specified condition or a specified state within a given time and under a specified conditions. You can compare this definition with that of reliability. They look similar. So this is also a basic probability. You can't say with certainty. And also in a given condition, like maintainability can be different for a different operating conditions, and during given defined time it has to be done or task has to be performed. Often maintainability is expressed in terms of mean time to repair. Mean time to repair means, like, if I am repairing a task 10 times and every time it taking a different time. So if I take an arithmetic mean, that will give me an indication of maintainability index, maintainability of that particular item. And this is the commonly used terms. Now we'll say, what is the objective of maintainability? The main objective of maintainability is to reduce the maintenance time and cost. Also, you can estimate the labor hour needed to repair the system or maintain the system in an operating state using specified resources. What is the outcomes? What is the outcome of maintainability? Like, you will get an increased availability because you are reducing the downtime, or you can reduce the cost. You will be efficiently using the maintenance resources. Now a good example, some good examples of maintainability. Very good example we see every day. We change lamps in our home. Lamps can be manufactured by Philips or by Osram, but we don't think, because each make lamp can fit into our home. That's the interchangeability. We don't bother about it. But remember, if you have a car and you are using a car, Volvo car or Mercedes, and you want to bring a wiper, windshield wiper from Volvo to BMW car, it won't work. That's a poor, bad example of interchangeability. So home bulbs being used at home are very, very good example of interchangeability. Accessibility. When you want to repair something, when you want to do something, it should be very easy to perform the tasks. See the person, he's performing a welding task and he has to lie down on the ground, and I can tell you many times task is not performed properly due to inaccessibility, because designer has failed to understand how a person can repair it. And you will see it. Next topic is serviceability. If you have a component designed for maintenance, it should be easy to service. A simple example is a fuses, electrical fuses in our home. We just open and replace by next fuse without thinking. Or this is a very bad example. If you see, to open these nuts, you need two tools here. But this is a good example. It's a simplified example. One has to think while designing. Other design is a modular design. Many times, especially very popular in electronic industries, something goes wrong, you change the whole circuit board and bring a new circuit board. It's much easier. In fact, this concept is also being adopted by mining industries. I have seen many times, if a loader working underground and engine has problem, it takes more than, let's say, 4 hours to repair that. They will bring a new engine, put it there on the machines in 2 hours. They prefer not to lose production for 2 hours if it is worth, if it is economically justified. So this is being adopted by many other industries, but it started with electronic. And of course, also a design for upgradation. You can upgrade your computers, upgrade your computer systems by putting new cards, new memories, etc. That's also part of maintainability, can be accepted. So when I'm talking about maintainability, you can feel it's very near maintenance. What is the relationship between these two, maintenance and maintainability? So maintainability is nothing but design characteristics aimed at minimizing service, inspection and repair times. So you think about maintainability during design phase, whereas maintenance is an act of repairing or servicing a machine or an equipment. You remember. So maintainability facilitates and decides how much time it will take during maintenance actions. So maintainability and maintenance are very closely related to each other. And maintainability characteristic decides how much time and what resources you need to perform the maintenance actions in future. And that will define the maintainability characteristics of equipment. Once we have defined maintainability, so we know about reliability, now we'll define availability. So we are at the availability concepts level. So if you look, why should we think about availability? We know reliability, like how many times things are failing, how often it is getting repaired, but many times it is more important to know the fraction of uptime. You are much more interested to know how many hours my system is available, how many hours my machine is available. That's of interest than how many times it is failing. And that concept is expressed through availability concepts. And the concepts of uptimes and downtimes are often as a function of reliability performance, because how many times it is failing, downtime by maintainability performance, and also we have not talked about maintenance support performance. I'll be introducing you. This is also very important because maintainability is important, but maintenance support performance is even more important in certain cases. I'll be coming back to that in a couple of minutes. Please look at this definition of availability. So availability is the availability of an item to be in a state to perform a required function under given condition. This is very important. You remember from the reliability definition, from maintainability definitions, given condition. It's very important. If you use the same machine in different condition, you won't get the same availability. At a given instant of time, here it is a difference. It's not an interval of time. It's a point of time. It's available or not available. Or given time, here comes the for a, over a given. It's not for a given, over a given interval. Is it available or not available? Assuming that required external resources are provided. This part, that required external resources are provided, that comes the maintenance support concepts. And like reliability, availability is also a probability, and it is expressed in terms of probability. Common definition. This is a very common definition of availability. Uptime divided by uptime plus downtime, means uptime divided by total time. You get a fraction. If you multiply it by 100, you get a percentage availability. So simple is that. And what happens when you start calculating reliability a little bit more using the data, then you use the concept of mean time between failure. That's arithmetic mean of all time to failures. And if you divide by mean time between failure plus mean downtime, you get the availability value. So if you look carefully, this uptime is expressed here in terms of mean time between failures, and this is a total time available, the machine was available, MTBF plus mean downtime. So you get a concept of total downtime, total available time, sorry. So availability is an appropriate measure for performance of repairable item, an item which can be repaired. So people usually say, we don't talk about availability about the bulbs, but we talk about availability about let's say hydraulic pumps, car, big trucks, machine or excavators. So there are totally some different concepts, and availability is usually used for repairable items. Looking into availability more detail, we talked about reliability, we know maintainability. We have to define maintenance support. I'm coming back to that. Availability is design tolerances. If you don't have design tolerance, you will not get the high reliability, because during manufacturing other defects will be entering. We have design margins that influence the characteristics, reliability characteristics, operating conditions during operation phase that will impact the reliability characteristics. Similarly, maintainability, these three defines the uptime as I presented during definition of availability, how uptime is defined. Now coming to maintainability. Maintainability is like during you define tools and facilities, what facilities you need to repair the item in a given time. So facilities, understanding of the design of facilities is a very, very important exercise during the maintainability. What tools are needed? If you don't have the right tools, it will take longer time. If I'm trying to open some box, jar cans, if I don't have proper cutter, it will take longer time. So simple are the. Also type of spares. Maintainability designer, he also perceives that you should have spares available, or you should be able to order the spares in a given time. That will define the maintainability. Accessibility, as you saw in the pictures, photos earlier, like you have to perform the task in a very unergonomic way, it will take longer time. So you have to think about that also. And modularization is the best way, like how quickly you can change the systems, like even fuses is a good example. That is also like you change a bad fuse to the good fuse. You remove the bad ones, put the good ones. That's a good example. And interchangeability, like you change like a bulb example I say. And modularization, best example is the circuit board. People take the electronic circuit board and replace by good ones. This concept defines the downtime. If I have the not correct tools, you don't have the correct skills, you don't have correct spares, it will take longer time to bring the system into operating condition. If accessibility is not good, if serviceability conditions, it will take more time to do the preventive maintenance actions. So concept of maintainability defines the downtime, how much downtime we are going to encounter during the lifetime of the equipment or a system. Now let us look at the maintenance support. We have defined maintenance support earlier. So we'll look at the definition of maintenance support. And you will recognize some of the words very easily. The ability of a maintenance organization under given condition to provide upon demand the resources required to maintain an item under a given maintenance policy. So more or less the similar things like given conditions, probability, all these things are here, because this is the most important item that differentiate between the successful organization or an organization which are not achieving results, because many organizations are operating same machine but they get different output because they have a different type of maintenance support. This is also very important part in understanding the concepts of availability. So coming back to here, what are the things that is important, like procurement of maintenance tools and facilities. Even the designer has defined that you should have a particular tools like this to maintain, but you don't buy it, so it will take longer time to perform the repair, or you don't have the right documentation, you don't have the right training of the people. So everything is very important here. So all these three concepts together combines the concepts of availability. And maintenance support also influences greatly the downtime for a system. So you have to, if you are working in industry, you have to think a lot about this maintenance support part of the availability concept. Now I'll be presenting different type of availability used in industry to describe the concepts of availability in different context. The first one is inherent availability, second one is achieved availability, and third one is operational availability. Let us look at the inherent availability. Inherent availability is defined exactly like probability availability definitions. It is a probability that a system or equipment, when used under a stated condition in an ideal support environment. Remember, ideal support environment. It's very important part for this definition. Readily available tools, spares, maintenance personnel, etc. will operate satisfactorily at any point in time as required. Like you demand that system should function, it is functioning. It excludes preventive maintenance actions. When you are calculating availability, inherent availability, you don't consider service time, like you will stop the machine to change the oil, no. Or logistics delay, there are not people. This is not considered. System fails, it starts getting repaired automatically. And this is like very true for a spacecraft, like a system that are autonomous systems, they are working self-maintaining system, etc. are built around that concept. How to calculate inherent availability? It can be simply calculated by mean time between failure divided by mean time between failure plus MTTR, that is mean time to repair. And you remember, basic concept, this is the uptime, this is the total time, and it excludes all delay, services, etc. So you get a pure inherent, by the word generic, the meaning of the word is like it's inbuilt availability. Now we'll look into the concept of what we call achieved availability and how it differs with inherent availability. Here definition is same, ideal support environment, but it includes preventive maintenance actions, but it excludes all the logistics delay. That's the main difference. And how to calculate it? Mean time between failure divided by mean time between failure plus mean active maintenance time. It doesn't consider any delay, logistics delay. What is the logistics delay? Like I don't have a mechanic available and I have to wait 5 hours. Those things are not considered here. Those times are not calculated, not used in calculations. So you get this definition. Now we look at the most commonly used concept of availability called operational availability. If you go to a company and ask what is your availability, they will talk to you about operational part. They don't talk inherent, they don't talk achieved. They will say operational availability, even though they don't use the word operational. How to calculate operational availability and what is the definition? It is the probability that a system or equipment, when used under a stated condition in an actual operational environment, will operate satisfactorily when called upon. And it includes all delay, logistics delay, preventive maintenance actions, everything. So calculating this operational availability, the concept of MDT includes two parts. You say active maintenance action and mean waiting times, like waiting for spares, waiting for mechanic, etc. and it has a repair times, logistic delay, and administrative delay. Once we have seen the concept of availability, we look into the concept of unavailability. Many times it's of no value to know about the availability. Look at the alarm, fire alarm in your home, in your houses. You don't bother about it is available or not, but it should work when I want it to work. And there it becomes like that. It is available all the time, but sometimes it doesn't. When I want it to use, it doesn't work. At that time, concept of unavailability becomes very, very important. On demand availability. And in that cases, many times what happens, so time it is available is not of much use. Like say a system is available for, let's say 99.5%. I want to increase availability by 0.1. It has got no meaning. But if I'll say this 0.1% increase in availability will reflect in unavailability reduction by, let's say 50%, that makes a sense. So many times for alarm, etc., we use the concept of unavailability. How much unavailability is reduced? That's important. And that concept is reflected in terms of unavailability concepts. Now, I will introduce a very important, I will close this topic with a very important example. We call it like avoid a common mistake. When you companies are signing agreements, and many people use the word only availability in their agreements, but they forget to talk about reliability. Let us look at this example. We have two systems like model X and model Y, and I have to select between these two. It has a mean time between failure of model X is 100 hours and model Y is only 10 hours. If mean time to repair is 10 hours, for model Y it is 1 hour. And if I write a contract, let's say my contract says I need a 10 upon 11 or 0.99 availability. What happens? I get an availability, same availability in both the cases. I will ask you, which one will you prefer to buy if both has the same price, same cost? Very simple answer. Everybody will prefer to have model X. Why? Because it has a higher reliability. Why it is important? If your system stops very frequently, mostly in a factories, in a process plants, if one system stops frequently, it will make other systems idle, and cost can be enormous. So even though both the models are delivering you the same availability, we'll prefer to buy the model X. So don't do a common mistakes and only focus on availability. Think about reliability also. Okay, now summarizing this topic, let's look. We looked at the why R and A both are important and both should be considered. We learned about the availability concepts, different type of availability concepts being used in industry, and also we learned about maintainability, how reliability and maintainability constitutes availability concepts. Thank you.